potential energy, types of potential energy. Now we are moving on to conservation of energy. What is conservation of energy, children? You have learned in small classes. Ninth. Unmute and tell Gauri.
Energy can neither be created nor be destroyed, but can be transformed from one form to another.
Yeah, very good. So that is conservation of energy. Those who don't know, you can write it because this we learned in 9th, 10th, everywhere. So conservation of energy. Energy neither be created nor be destroyed. It only transforms. Now we are going to prove how a potential energy and kinetic energy conversion taking place, and how this conservation law of energy is verified. Whether whatever we say, we have to prove it. So that is what the next thing. So conservation law of energy states that energy neither be created nor be destroyed. It only transforms. It only transforms from one form to another. Okay. So shall we go to that? And what is this GP? Our heading is conversion of GP, gravitational potential energy. GPE, gravitational potential energy into kinetic energy, and verification of conservation law of energy. It is also we have learned in 9th standard, but how many learned, taken importance that time we don't know. So we are going to learn once again that one. Regarding an object is falling under gravity. So let us have a small object A. Small object A. So we have to assume that small object A falling. Now an object O falling from a position A, then it come to B, then it is come to C. So we are just considering an object is falling. An object we give name as O. An object O, first it was position was A, and then it come to B, and then come to C. And total height from where it is falling, that we assume H. We assume H. And we assume the distance between A and B. We assume it is X. Then what will be distance between B and C? Can you tell me? If A to B is X, total height AC is equal to H, what will be BC?
H minus X.
Yes, H minus X, correct. So all the input we got it to prove that how GP converting or conservation law of energy. So you can write it. Consider a body of mass M. Consider a body of mass M. Consider body of mass M placed at a height H. Placed at a height H. Having I'm writing short form GPE, that is gravitational potential energy, mgh. Gravitational potential energy, mgh. When the body, next line, when the body falls from H, when the body falls from H, GPE is converting into kinetic energy. GPE is converting into kinetic energy. Thus, by conservation law of energy, thus.
Can you say again?
When the body is falling from height h, Gp, gravitational potential energy is converting into kinetic energy. Kinetic energy. Thus, by conservation of energy, sum of kinetic energy and GPE, sum of kinetic energy and GPE remains constant. Okay. So this is our introduction. Now what we are going to see in that, we are going to find out what is the total. So already we know, according to conservation of energy, potential energy is the one which is transforming. So from here we'll understand loss of potential energy actually is equal to gain in kinetic energy. From this statement, loss of potential energy actually is equal to gain in kinetic energy. From this, what we understand, loss of potential energy equal to gain in kinetic energy. That means, for example, you know that a total Gp at a particular height is 100 joule. Just think, while it is coming to point B, it has used 40 joule. That means 40 joule is the kinetic energy that has been taken from 100 joule. So 40 joule kinetic energy means it lost 40 joule of potential energy because of the conversion. Clear? So according to us, we consider the maximum energy at a particular height will be only potential energy, because potential energy is the energy possessed by the body at a position. So this object was at a particular height h. It was at rest. Then it started falling. From A it come to B, then come to C, where C is the ground. So C is the ground. So whatever conversion can taking place from potential energy to gravitational energy, this will be loss of potential energy and gaining kinetic energy. Thus, total energy of this entire process will be their sum. Total energy of this entire will be their sum. So that's the meaning of sum of kinetic energy and GP remains constant. Okay. So now what we are going to do means, at A, how much is the total energy? At B, how much is the total energy? At C, how much is the total energy? In all the three cases, we have to get the same value. Here also same, here also same, here also same. So without applying digits, we are going to prove it in terms of these letters, H, S, H minus X, mgh. Because already told, potential energy is Gp is mgh. So at height, so first case we'll do, object is at A. Object is at A. That means object is at rest. That means object is at rest at point A. So velocity is 0 because it is not moving. Thus, kinetic energy is 0. And already it is mentioned in the introduction statement, GPE, total energy is at that point is mgh. So, total energy at A will be sum of this. 0 plus mgh, you will get mgh. So let us give as 1. So we got the answer as mgh. Same answer you should get at B and at C. Same answer you should get at B and at C. So this is first case we proved. When object is at A, it was not even started falling. It was at rest. So it has only potential energy. Since it is at rest, no velocity. So gradually kinetic energy going to be 0. Mathematically kinetic energy going to be 0 because no velocity. Okay. Shall we go to the at point B? Next case. At object is at point B. Okay. When the object is at B, due to acceleration due to gravity, kinetic energy at B, you have to find out. You don't know. So what we have know. So if you look at the picture, when object is coming to 0, this much already potential energy out of mgh, some of the energy already lost in terms of kinetic energy. Means lost means it converted into kinetic energy. So at this point, now how much is the energy for object? How much is the potential energy? Total energy was mgs. Now object is at B. So only remaining potential energy will be energy which needed for object to reach here. I repeat once again. You have to calculate kinetic energy at B. So if you want to calculate that, first we should know how much potential energy remaining. So already from here to here, some amount of energy is used that will be equal to the kinetic energy, and remaining energy what the object is having at this particular height. Are you getting me? So when object is at A, total height was h. Now object is at B, what is the height now remaining? Or at this position, what will be the potential energy of the object? Anyone can tell me? Up to this already become kinetic energy. My question is, at this point B, this is the height, it has to be covered. What is the potential energy of the object at B now?
mgh minus x.
Yes, mgh minus. Are you got idea? Whatever is there, it is not mgx. Why? This mgx already converted into kinetic energy. So what is only remaining at this position is energy which needed for the object to reach here. So the potentials, just imagine the object is now stood here for a fraction of second, object remained here, then naturally this is the potential energy. Okay, so with that idea, we have to find out kinetic energy at B. We will find out. First we will write out. Thus potential energy at B, mg into h minus x, and now we have to find out the what is kinetic energy at B. So for that we have to consider third equation of motion. What is the third equation of motion? Velocity position relation. What is that? What is that equation, children?
2as is equal to v square minus v square.
Velocity position relation, third equation of motion.
2as is equal to v square minus v square.
So that is what you have to consider. Third equation of motion, that is v squared minus u squared is 2as. Here you have to find out the kinetic energy. Here our equation is mv square. You have to first to find out what is v. Okay. So for that we have to use this equation. So v square equal to, take minus u squared here, u squared plus 2, acceleration here is 2g, since it is coming in the direction of gravitational force, it is positive 2g. And what is the distance is covered at this point? We assume it is x. Okay, s is equal to x. So 2gx. And I already told you, when an object is falling, initial velocity going to be 0. When an object is moving upwards, maximum height, final velocity 0. When object is started coming, that is the initial velocity. The u squared is equal to 2gs. Therefore, our equation is going to be v square is equal to 0 squared plus 2gs. So we can substitute in this kinetic energy. Thus, what is the kinetic energy? Kinetic energy at B is equal to half m 2gs. V square, no? It is V square. V square is 2gs. So 2gx Nice fun. Okay. Okay then, we'll continue with that. Before that, we have to stop it again. That's all. Okay, children. So, kinetic energy, we already got things I am writing here. I am rubbing the beginning and all. So, we will get kinetic energy is equal to half m into 2gx, 2 cancel. So, now what we are getting? Total energy. So total energy at B, already we got that one mg, potential energy plus kinetic energy, mg h minus x plus mgx. When you expand here, mgh minus mgx plus mgx, mgx minus and plus mgx got cancelled. So at point B also energy is conserved because we are getting the same equation. Okay, now we are moving on to last one. Nothing to calculate there, it is clear. Object at sea. What we have learned? When an object hit on the ground, full kinetic energy, potential energy will be fully converted into kinetic energy. Therefore, potential energy is zero at that point. Thus, write down kinetic energy at sea is equal to, again, we have to use that equation to find what is that? Half mv square. V square is equal to u squared plus 2gh. This is going to be 0, 0 plus 2gh, and potential energy at C is equal to 0. So our equation of kinetic energy at C will be half m, 2gh again, 2 cancel, you will get mgh. So total energy at C, that's equal to 0 plus mgh is equal to mgh. So in all the cases, we are getting total energy mgh. Thus, we can say that conservation of energy is verified. Okay? Any doubt, children? So only one thing you have to understand in that picture. Try to understand the picture. A, B, total height is h. I repeat once again. We assume A to B is x. From B to C is h minus x. At A, kinetic energy is 0, potential energy is maximum. So we will get mgh. Now when you object already reached at B, potential energy going to remain potential energy is mg into h minus x. Then we found out the kinetic energy at that point by applying Newton's third equation of motion. You got it 2gx, 2 cancel. Then when you add it together, expansion, and you add it together, we are getting mgh. Then we come at C. So already we have learned that when an object is falling, velocity is increasing. So the moment it hit on the ground, kinetic energy become maximum. So potential energy 0, kinetic energy is there, and then what we are getting? mgh. So from this we prove that law of conservation of energy is proved. Okay. So that's about it. So similarly, we have to prove potential energy of a spring. That I will take it in the next class. We may not able to complete. So 5 more minutes, we can just understand two types of forces. Okay, two types of forces: conservative force and non-conservative force. What do you mean by conservative force and non-conservative force? So first we will learn conservative force. Conservative force. What is conservative force means? The force of the body which is acting on an object which is moving, or work done by an object if it is fully depending upon the initial position and final position. It is not depending upon the path which travel. Okay. For example, to come to Mala our school, we can come from Alva, we can come from Salakudi, we can come from Korati route, we can come from other Kodungalu route, everywhere is there. But conservative forces does not depend upon whichever path you come. It only depends which is your initial point. If it is in final point is Mala, initial point maybe Alve, Korati, so and so. Okay, so it is only depend upon initial and final point, just like a displacement. Okay, so that is known as conservative force. We can write down, if the work done by the force, in a moving body work done by the force in a moving body is independent of path traveled, but depends upon but depends upon initial and final position. Depends upon initial and final position. Then we can say it's a conservative force. So example, we have gravitational force. Gravitational force is a conservative force. Wherever you are in whichever part of the earth you are, it will attract you. It doesn't depend upon you. Okay. Whether you are in America, whether you are in Arab countries, earth will be attracting with the acceleration due to gravity. So it's a conservative force. Does it not look out where you are? It acts you. Okay. Next one, non-conservative. Non-conservative, from this itself you know. It will be reverse order. Yeah. It will be reverse order. That is, a work is said to be, if the work done by the force on a body moving between work done by the force on a moving body moving between the points depends upon the path traveled by the body. If the work done by a force on a body moving between 2 points depend upon the path traveled by the body. Example, we have so many forces. One is frictional force. Frictional force is the path. Whichever path you travel, it will pull you. Viscous force, that is the force in the air. Viscous force in the air, force in the fluids. Okay, so all these are non-conservative force. Okay. So children, I am winding up the session. So I think one more chapter, one more class, we will finish this chapter. Okay, it's a very small chapter, not much difficult like motion in plane and motion in straight line. And you see those two chapters are very important for our +2 also. So please concentrate on motion in plane and motion in straight line in this. Okay, thank you.